The undersea domain is growing in importance as an arena for military competition, commercial activity, and scientific research. A range of cross-cutting enabling technologies, communications, navigation, power, and sensing are the unsung heroes of the mission to promote greater undersea transparency and access. Welcome to the IQT Podcast. I'm your host, Vishal Sandesara, and today we continue our three-part exploration into maritime innovation. Today's episode will take a deeper dive into some of the hardest challenges in undersea technology, startups that are tackling them, and why it all matters. Joining me on the show are a number of guests: Chris Shaw, Tommaso Melodia, and Pat Mitchell. Welcome to all of you. I'll do a quick and brief introduction to each one of you, and then we'll get started. Chris is the CEO and co-founder of Advanced Navigation, an AI-based robotics and navigation technology company. Chris and business partner Xavier Orr launched Advanced Navigation upon discovering a gap in the market for small, robust, high-performance autonomous navigation solutions. Tommaso is the CEO and co-founder of Hydronet, a startup that builds programmable and AI-driven underwater wireless networks and data collection systems. Tommaso is also the CEO of BioNet Sonar and a professor of electrical and computer engineering at Northeastern University in Boston. And Pat Mitchell is with IQT's National Innovation Policy Team, where he researches issues at the intersection of technology, national security, and policy. Pat joined IQT a year ago after receiving his master's from the Harvard Kennedy School. He's the author of a recent IQT report on innovation in undersea technology, and his other research interests include digital infrastructure, global tech competition, and cybersecurity policy. Welcome to you all. Thank you for being here. Really excited about our conversation today. So why don't we start with Pat? Pat, you wrote a paper very recently. I had the pleasure of reading it, actually. And to our listeners who've had the pleasure of listening to the first in this three-part series, you've actually heard a bit of his work as the opening intro to the very first maritime podcast we did in this three-part series. What was the upshot of your paper? And in a nutshell, why is undersea enabling technology so critical?
Yeah, thanks, Vishal. So the paper picks up on one of the threads that you guys discussed in the first podcast in this series on undersea enabling technologies, and really getting into the question of what's holding back our ability to better understand and operate in the undersea environment, which is, of course, a famously challenging domain. And in that episode, of course, as Abby put it in that podcast, she predicts the undersea is about to become more affordable and more accessible. So one of the questions that the paper was tackling is, where do we need to focus our efforts to usher in that bright new future, which, of course, is these undersea enabling technologies. Satellites and aerial sensors, as you may be aware, are of limited value in the undersea domain because visible light and radio waves don't penetrate the water very deep. So to map or to monitor, and certainly to operate in the undersea domain, you really have to have a physical platform that's physically there. Autonomous vessels, both AUVs and USVs, are particularly exciting because they break one of the long-standing requirements to have crewed ships. You don't need to feed them. You don't need to pay them while they're out there. And in theory, you can spread them all around the world to perform a lot of these functions. But the problem is, of course, AUVs in particular tend to be expensive. Many of them are millions of dollars, and then functionally constrained in a lot of ways related to those four enabling technology areas that you talked about at the outset. Particularly the data that they can communicate, their ability to navigate in a GPS-denied environment, and then their endurance. So these are hard technical problems. There's also a market challenge associated with them. There are a lot of exciting advances in these areas, some very cool companies doing work in these areas. We're fortunate to have two of them represented with us today. And the question is, what can we do to create more of that? So, yeah.
Let's take a sort of a zoom out real quickly. We'll start with Pat, and then I'd love to hear from Chris and Tommaso as well. Why is the undersea environment important in the first place, and why is now a good time for whether you're a policymaker, whether you're an entrepreneur, a startup, or a large incumbent? Why is now a good time to be in that domain? And what's new? What's sort of either up and coming or already here on the horizon that our listeners might be interested in learning? We'll start with you, Pat.
Yeah, Vishal, of course. So in terms of current events and domains, I think of four big areas. The first is great power competition, military competition. As we've seen in the Black Sea, the ability to use expendable, lower-cost assets to deny large capital ships the ability to operate has been one of the big takeaways from that. And unfortunately, there's a lot of competition and hotspots in the maritime domain that we're seeing around the world, from the Red Sea, of course, the Persian Gulf, potentially the Pacific as well. So the ability to have uncrewed and more expendable assets is at a premium there. Every year, there's more critical infrastructure that's under the ocean. The ability to talk to our friend Chris in Australia is, of course, via one of the 500 or so subsea cables which transits the ocean, and the ability to repair them and to monitor and protect them is of course, very valuable. Then, of course, there's deep sea critical minerals, polymetallic nodules, which sit on the seabed containing minerals which could be key for the energy transition. There are many companies which are looking into the technical viability of retrieving those. The ISA, the UN agency, which is responsible for setting the regulations for that type of deep sea mining, appears like it may be soon issuing the regulations which will allow that to go forward. And then finally, there's issues of conservation. The High Seas Treaty, the biggest UN agreement since the UN Convention on the Law of the Seas in the 1980s, recently was enacted last year. And so there's, of course, continued interest in the ability to understand and conserve the seas too.
That's very helpful. Chris, your thoughts? Why now? What's new?
Yeah, well, I think as Pat mentioned, in the past, this technology was very expensive. And I think as technology is advancing, becoming more inexpensive and more accessible, it's creating a greater emphasis on our ability to interact with the maritime environment, which, as Pat mentioned, is critical to our lives, from communication to transportation and freight. I mean, as we know, most of the world's sort of critical shipping and freight all happens by sea. And our ability to monitor, protect, reduce greenhouse emissions and kind of get more efficiency in that industry is also a sort of critical driver here.
Great. Tommaso, your thoughts?
Sure. Without repeating what's been so eloquently discussed by Chris and Pat, I think, availability of hardware, software, and algorithms, specifically AI, that can be executed on unmanned underwater systems. That's something that we didn't have from a technological point of view. And why it is exciting to work on ocean-related technologies is because oceans are a source of economic growth. They've always been. But they are the core of the blue economy, which is estimated to grow to more than $3 trillion in the next few years. And they are also a source of food, right? 70% of the population get the primary source of proteins from oceans. So that's,
I'd like to give our listeners a sense of why this domain, the undersea environment, is so difficult to operate in, and perhaps what both Chris and Tommaso, your organizations, are doing in this regard. Why don't we start with you, Chris? Advanced navigation. How is it addressing these challenges that we sort of brought up at the top of we sort of alluded to these enabling technologies also present a sort of set of challenges when thinking about operationalization. I'd love to hear what is it that advanced navigation is doing, with challenges navigation and in the undersea environment, and then over to you, Tommaso, to sort of learn a little bit about Hydronet and what it's doing for connectivity in the undersea environment as well.
So there's two things I would highlight that are challenges from our perspective in the undersea domain. First of all, as a company, we do things that go into space and we do things that go underwater, and just from a reliability and robustness of deployed hardware, we find it actually sometimes more challenging to develop technology that goes underwater, because you've got extreme pressure, corrosive kind of environment that causes most metals to degrade, and actually putting things in vacuum sometimes is actually easier to achieve than doing that in the subsea environment. So any company, first of all, deploying anything in that domain comes across that challenge. But from a navigation perspective, the obvious one to call out is today in our daily lives, we're so reliant on GPS. So since the US opened that up to commercial use over 2 decades ago, literally every single individual person is reliant on that, from a mobile phone, the communication networks on it, through to our cars and even just day-to-day lives. The thing is, though, GPS is not available underwater. So already you have this challenge that there's no global infrastructure that exists today to allow anything to get from point A to point B and know exactly where it is underwater. And that's where technologies like ours come into play to solve that challenge and help operators of autonomous assets know exactly where they are, which is a critical thing in an underwater environment, because often, especially with the autonomous platforms, the operator has no live link, typically, especially if it's hundreds of kilometers away, to that asset. And it's critical that it can navigate on its own to get from point A to point B.
Well, so for connectivity, right? Today, when you operate in the terrestrial domain, we take connectivity for granted, right? And we also take for granted something that we call the Internet of Things, right? What's the Internet of Things? It's this distributed interface between the physical world, right, where we live and operate, and the digital world. And now, if you need data that describes the features of an environment, you can get it in the terrestrial world, right? You can take decisions in real time or on longer time scales based on this data, because you have this continuum from sensing to wireless communications to visualizations and data analytics, right? And all of this becomes much harder in water, because sensing information is hard per se in water, but wireless transmission is super hard because radio frequency signals, and I think, Pat, you were alluding to that too, what we use in air for Wi-Fi, Bluetooth, 5G, they just don't propagate in water, right? So in water, we have to use a combination of different signal modalities to send data wirelessly. And specifically, we're using acoustics, right? So sound, that carries digitally modulated information. We're also using ultrasonic waves, basically inaudible sound, and visible light, light as a carrier of information. And Hydronet is a DARPA-funded venture, spin-off of work that we've been doing at Northeastern University, that is developing the first software-defined networking technology for the underwater domain. What does that mean? It's based on modular hardware where you can connect different boards like Legos, in a sense, to create the service that you need, and then software that implements the functionalities that can adapt to the specific environment. So Hydronet is basically trying to bring the internet underwater, the Internet of Things, we should say, probably underwater, enabling this ability to make decisions based on ocean data, through this continuum of sensing, communication, analytics, and visualization.
Very interesting. In most fields, but especially underwater technology, it's rare to find a product that is both cheaper and high performance. I'd say that if you can, you've actually found yourself a fairly unicorn product. You should hang on to that and ride it out as long as you can. But you, Chris, when it comes to advanced navigation, you have managed to do both in sort of the digital fiber optic gyro. How are you using software and AI to get more out of existing hardware and drive sort of more efficiency and more value out of existing sort of platforms in that regard?
Yeah, so I think like a lot of businesses today, our thesis is really that really unique software can solve challenges with greater flexibility and high performance than trying to build sort of really complex sensors. And I think this kind of approach comes from the, I guess, mobile kind of telecommunications industry, where several decades ago we all had analog sort of phones, and the progression to kind of digital technology has opened up so many more opportunities to constantly improve performance through software updates and other things like that to how things communicate. So I guess in essence, we have the similar approach with navigation, that we've used machine learning and artificial intelligence, as well as some quite unique signal kind of processing techniques in our actual sensors to use much less complex hardware and actually solve a lot of challenges in performance in the software domain. And the obvious benefit to that is you get a greater reduction in size, power, and cost. The complexity obviously comes from developing and maintaining that software. And but once you kind of, as you sort of point out, if you can kind of find that unicorn, then you want to really exploit that and hold on to that. So that's how we've managed to achieve that kind of performance and cost and size reduction all in one.
Tommaso, over to you. You're also the CEO of BioNet Sonar, a medical device company, and you have many other research interests in wireless connectivity. You mentioned IoT. I'm also aware that you're interested in 5G, Open RAN, for example. How do you see advances in other domains translating to the undersea environment from your context and perspective?
Well, that's a great question, and indeed, I've been doing a lot of work with my university hat on Open RAN in the last few years, right? And the world of 5G and cellular communication is evolving towards this concept of Open RAN, right? Instead of having a monolithic piece of hardware that contains embedded in the hardware all of the functionalities that you need to provide cellular connectivity, and this monolithic piece of hardware are traditionally built by a vendor that has expertise in the entire value chain, right? Now, with Open RAN, we try to disaggregate the hardware into smaller, simpler components that are connected through open interfaces, right? Now, then build all the intelligence of the system on software rather than on hardware. And this software runs on generic computing hardware, or let's say as generic as possible. And then you try to control the system algorithmically through AI and possibly data-driven algorithms, right? And so now this is very similar conceptually to what we're doing with Hydronet in the undersea domain. And that's and we've taken a lot of inspiration, obviously, from what was happening in the world of cellular connectivity. The key is the ability to learn to operate in specific environments and get the system to continuously adapt to operate optimally in the environment. And that's something that you can do when you're operating with a generic hardware that runs software on top of that, algorithmically controlled, that can adapt the behavior of the system to the specific environment. So this connects very well to the theme of software and AI and getting the most out of hardware with the power of softwareization and algorithmic control. It's really at the core of what we're doing.
I see. I have a sort of a off-the-wall question for both of you. Chris, maybe you answer first, Tommaso, you second, and Pat, if you have thoughts, by all means. Taking a step back, artificial intelligence, the common trope is always, good data. You need a lot of good data to do just about anything that you might want to do when it comes to a particular task, whether it's classification, whether it's, recommending a navigation route or something thereof. Could each of you speak to a little bit about, the high availability, low availability, or no availability of viable, good quality data in the domains that you're concerned with, especially when we think about undersea technology and the AIs that we're all discussing here that sort of enable a lot of these things?
Yeah, so happy to take that first. From our perspective, especially in the underwater domain, there's a huge lacking of data right now, especially of high quality. And that's just a nature of the environment being challenging, but then also the capture technology being not as advanced previously as we'd like, and then also just the vastness of the ocean. So we've still barely mapped all of the environments of the ocean to a high degree. So the workaround to that is, I think, really relies then on adaptable models that can do real-time learning as well, and that's where a lot of our emphasis has been on some of the applications we're doing with visual and acoustic object kind of detection. There's a bigger reliance on smaller kind of training data and more real-time kind of adaptable learning.
I see. Tommaso, your thoughts?
In our domain, there's very little to no data available for experimentation, for research. The only effort that I think is happening in this space is something that was launched by MITRE. MITRE has developed a project called Blue Nerve, funded by the Massachusetts Technology Collaborative. They're trying to create an online network that will improve accessibility of maritime data for businesses and other organizations. So it's in the early stages. We're one of the partners, we're one of their nerves, so to speak, of the Blue Nerve network. And it's a great project, and I stay tuned. I think it will provide very helpful data and information.
Very good. And
And sorry, Vishal, I'll add just one additional point. I think there are some companies too which are viewing this lack of data both as a limitation but also as a business opportunity. So you see several companies which are in the data as a service industry, whereas in the past they may have considered selling an uncrewed surface vessel or an autonomous undersea vehicle, but instead are looking to keep those in-house and then sell the insights to customers, whether it's a defense customer or a commercial customer.
That's great. Thanks, Pat. Chris, a few years ago, Advanced Navigation announced a partnership, I think, with a quantum company, an Australian quantum company called Q-Control, I believe, to work on quantum navigation, which sounds pretty awesome, actually. Could you explain, first of all, what quantum navigation is, just because I think it sounds amazing and the stuff of fantasy, but I'm sure it's a real thing and has very real life practicality. And secondarily, can you tell us a little bit about what that might do in terms of what that might do for next generation undersea, navigation and routing technologies?
Yeah, it certainly sounds really cool, doesn't it? But in essence, the quantum navigation technology is there's a couple of different approaches really that can be taken. So one is building traditional kind of motion sensors, but using quantum science, I guess, to achieve the sensing. So what I mean by this is traditionally you have things like accelerometers and gyroscopes that measure changes in acceleration, or gravity and rotation. And then from that, you can kind of compute navigation. Using quantum versions of those sensors, you can get much higher accuracy. So straight away from that, your overall navigation system can improve its long-term performance quite highly. The second approach is using things like the passive sensing nature of quantum sensors, so sensing gravity or even magnetic fields from the Earth or other objects that are large enough to detect these, and then having complex maps. But as we just sort of talked about in the previous topic, then the challenge with that is data. So these new approaches of kind of like gravity mapping or magnetic mapping navigation are just starting to kind of emerge. And then as the sensors become good enough to do the navigation, the challenge is then getting them out in the field and creating the maps for them to then use. So really amazing technology, what it can do. A good example I'll give is some of the quantum experiments that we have done or published papers by even university have shown the sensitivity of these sensors is enough to detect the gravity emitted from a human, which is just kind of mind-boggling to think about. So you have stories of people walking in the laboratory next door to where the experiment was taken. They're interfering with the sensing, basically, just from that person moving. So it gives you an idea of the magnitude of the sensitivity. But once you kind of unlock that, then you've got to work out, now we have to gather all this data to actually use it.
Yeah, that's pretty exciting. Tommaso, over to you. Exciting things that are coming that you're looking forward to or that you're anticipating that will sort of change or enable next generation undersea technologies.
So one thing that excites me is the ability to create mesh swarms of underwater undersea vehicles and drones that are interconnected, that can operate collaboratively in their sensing tasks, that are connected to the internet, so their tasks can be programmed. You can observe in real time what they're sensing, what they're seeing, and I think this might be a game changer in the area.
I'd like to sort of have an open question to all guests here as we look across the broader commercial market in this space. What are some of the, I guess, common challenges for startups that are looking to build a sustainable business when it comes to undersea technology? Why don't we start with you, Chris, and then we'll take Tommaso's thoughts after that. And Pat, feel free to chime in as well.
Yeah, so I think I'll sort of give two views on this. One is just the harshness of the environment. So it's really critical that whatever technology you're deploying in there is going to be reliable. Because I guess as a new business kind of moving into that space, if you can't hit that reliability aspect, it's going to be really hard to get customer traction. The second thing is understanding how to educate your customers on what your technology solves for them. So I think the challenge with this area that we're talking about is it's a very emerging area about what technology can solve in the underwater domain. So some people don't know actually that your product can fix a problem for them. So being able to get marketing material or communicate the challenges you're solving for the customers, whether it's safety, environmental reasons, it might be economic to do with someone that operates a port or shipping sort of channels. And so it's really important as a new business and coming into this area that you're really strong on trying to get across the message of what problem you're solving for the customer.
Makes a lot of sense.
So in terms of the in general of the challenges of undersea tech, right? I think what is challenging in undersea technology is also what makes it an extremely exciting field, right? It's highly interdisciplinary in what you're doing, what we're doing. For example, you need to understand hardware, software, energy, mechanical engineering aspects, pressure, etc. There's also a big gap between what you can simulate and model, and simulation and modeling are the classical tools of engineering, right? And there's a big gap between simulation and modeling and what you see when you test in the field, right? I think more than in other domains. And it's also, as Chris was mentioning, also it's expensive to experiment, and it's hard to get from something that works to something that works all the time, right? It works in a very reliable and repeatable and predictable way. And that's a challenge across the industry, I would say. And specifically to your question of challenges in building sustainable businesses, I think that there is an incredible opportunity for growth. There's a lot of applications that are quite diverse with respect to one another. A challenge historically has been to, the fact that attracting funding is difficult because there's few success stories and there's a lot of diverse industries, right? What you build for oil and gas is different from what you build for defense. It's certainly very different from what you build for environmental monitoring or aquaculture or recreational diving, right? But these are all areas where undersea technology can grow, but great ideas need to morph into slightly different products that can serve these different domains. And you have to build dual-use technologies that are often initially focused on defense, right? Because that's where a lot of the funding and the opportunities and the need for innovation comes from, and then can evolve into something scalable that can be much cheaper and applied to commercial markets. And that's, it's exciting but challenging.
Yeah, for sure. Pat, over to you.
Yeah, and on that point too, I don't have too much to add compared to two CEOs who have done this, of course. But I think Tommaso mentioned a few of the typical buyers, military, defense, government buyers in general make up a large share of the market. Commercial, it's oil and gas, increasingly offshore wind, aquaculture, looking at monitoring offshore infrastructure. One piece that I found interesting, and maybe, I don't know if this brings up any ideas for you guys too, is that in this area, it turns out that occasionally government is often more willing to experiment than commercial customers. And I guess this comes from a sense that is very sensible, where if you're operating an offshore oil rig and you're going to embrace autonomy and an autonomous vehicle, you have a lot to risk in addition to the imperative to bring down costs. So yeah, that was one of the interesting takeaways, talking to a couple of companies that perhaps counterintuitively at times government is pushing the envelope a bit more with its defense use cases than perhaps you'd expect.
That's an interesting perspective. Let's talk a little bit about bigger picture, sort of global and policy related topics. Any perspectives on U.S. and allied efforts to expand their autonomous and undersea capabilities? I'm thinking of AUKUS, Replicator as examples, and what needs to happen for them to be successful. Why don't we get thoughts from Chris and then Tommaso on that?
Yeah, so I think one of the first challenges is something that Tommaso is kind of solving for with his business, which is interconnectivity between assets. I think that's one of the first challenges really with some of these things like AUKUS that need to be solved. There's already steps kind of taking in this way where I think at a government level, they recognize that interoperability needs to sort of be a key focus as we build more and more attritable kind of undersea technologies. And that's something that I think hopefully we can start to see some more different standardization happening in interoperability soon, because this has already happened in the land vehicle domain, aerial vehicle kind of areas where you can kind of buy different technologies and plug and play them together pretty quickly to go on a platform. That is a lot more challenging in the underwater market, where it's still a number of different companies have fairly closed standards that don't work well or play nicely together. The other piece to that, I think, as well, is just also information sharing and collaboration. There's still, I think, a lot of work to do in things like AUKUS to work out how best different innovation groups can kind of share cross-border, because this is typically an area where in the past, I think lots of governments have taken a pretty risk-adverse approach and make it difficult and challenging sometimes for researchers to collaborate through the export controls and other things like that, which are a necessity, but we kind of need to look at how you don't let those stifle innovation.
Chris, just real quick for those that might not know, what is AUKUS?
Yeah, so AUKUS, I think, so the acronym is Australia, UK, US, and it's basically a trilateral partnership between the three countries. And they talk about there being two pillars. So pillar one is basically nuclear submarine technology, where the three nations are working on sharing existing technology, but then common joint platforms being developed with common technology for future decades as well. And then pillar two is kind of the more interesting one to most people, which is the innovation and shared technology areas. So there's kind of multiple streams have been called out there, but you've got things like undersea technology being one of them, and quantum technology, robotics. So all these kind of emerging technologies together, the three governments are called out that they want to collaborate and work more closely. And it's that old scenario of, I think each nation could get 80% of the way there working on their own, but you kind of partner all together and you get over the finish line much quicker.
Got it. Tommaso, your thoughts on allied efforts?
Yeah, I think so. These efforts are super exciting and they're based on connectivity, so that's great. We're involved with Hydronet with an effort is looking at integrating different technologies with the U.S. Navy, and I can tell you that it's extremely challenging. Right? There's the key to success is, I think, defining good interfaces, starting simple to enable a heterogeneous system to interconnect with one another, right? And then abstracting the functionalities so that you can use higher level intelligence and algorithms to control these complex systems in a coherent and cooperative way, right? And in a sense, the interoperability and abstraction of functionality is what made the internet, which is the most successful network that we've ever seen, right? A success. If we can replicate some of these basic principles in some of these efforts, I think they would be successful.
Pat, I'd like to get your thoughts as we're approaching sort of time and our voyage comes to an end. To use my first well-placed pun in this discussion. I'd love to hear about thoughts, ideas, messages you may have for policymakers interested in promoting U.S. and allied leadership in this critical domain.
Yeah, of course. Well, number one, read the paper. But I can, for those unlike Vishal who didn't diligently read every page, I can give a couple of thoughts. But yeah, I mean, building on the last question, the last point, there is a big interest in expanding the capabilities of these, what you may call attritable, the small, the many, the cheap platforms. And I think it is probably obvious to those who work in that domain, these are composed of subsystems, these enabling technologies, which include power, sensing, comms, navigation. And these are some of the hardest challenges that still need to be addressed. And I think at IQT, we talk about the innovation pipeline is going all the way from research and development at one end all the way through to commercialization and helping companies scale up. So I think there's efforts that can be made all over the place, all over this innovation pipeline. There's a lot of entities that are doing great work here already. Obviously, the Navy Office of Naval Research, in particular, that I know is working on this. DARPA, Department of Energy, NSF, and NOAA. So I think part of it is to reinforce the good work that those government organizations are doing, and then also, as Chris and Tommaso eloquently described, we have a global distribution of talent related to maritime technology, and ways to tap into that and integrate it are key.
Very good. Thank you, Pat. Pat, Chris, Tommaso, it's been a real pleasure getting to speak with you all today. Thank you so much for your time. On behalf of our listeners, we really appreciate it. And to you, our listeners, thank you for tuning in to today's episode of IQT Explains on the IQT Podcast, and the final part of our 3-part series exploring maritime technology. If you're interested in learning more about the maritime startup and investment landscape or open source activity in the domain, I encourage you to check out our other 2 podcasts. So you can find those on our website. Please make sure to subscribe to the IQT Podcast so you don't miss out on future content, and leave us a review or a comment to let us know what you think or what content you'd be interested in hearing more about in a future podcast. I also encourage you to check out IQT's website at www.iqt.org to explore more content about cutting-edge technology to support and deliver insights and capabilities essential for national security mission impact. Thank you until next time.